Mhm. Yeah, but I was, yeah, could you just, why don't you just lean over and use the keys here? Okay? Go ahead. Thank you. Thank you. Um, Good afternoon, everyone. My name is Jeremy Watson. I am a junior here at the University of District of Columbia. I am majoring in computer science, and today I'll be presenting on implementing the Virtual Security Operations Center. Uh, I just want to first, I just want to acknowledge Dr. Lam for helping me with this project, and also Dr. Morning for giving me the opportunity and funding to go ahead do this research. Um, so the general objective of this project was to implement a virtual security operations center that was proposed by our few students at the Hood College. So this was a paper written by these students, which described how a virtual security operations center may be developed with free open source software and how we will be able to evaluate its effectiveness according to various metrics of interest through automatic generation and injection of synthetic attacks. So what is a security operations center? Well, a security operations center is generally the centralized operations center where all the network traffic, network information, and ideally all the network configurations are monitored, where threats are also recognized and evaluated, and they're also C2. So what it does, it provides the means to log and visualize real-time normal anomalies to network activities. It also aggregates events or highlights and security status for each network set, and it provides surveillance of the physical environment. So a few methodologies of this project. So while I was doing this project, the first thing I did was to configure a firewall with the pfSense interface. So what the pfSense does, the pfSense gives us the opportunity to create a virtual private network through which we will be able to channel all the network traffic. And what this does is this gives us an opportunity to create um, a simple build a simple data monitoring point where we have all our data traffic, our network traffic going to a single point, so we can also go ahead and analyze, well, capture all the traffic that's going across our network, analyze that data, and detect any anomalies. All right, so another one of the technologies that we which we would use for this project is RAfana. And what RAfana does, it helps us with the visualization and it gives us advanced search capabilities. So what this helps us with is visualizing the network traffic so we can identify spikes, unusual anomalies, and we can also um, search for uh, activity above a certain threshold or being able to uh, visualize, see a visual representation of the activity in our network. So another network software that we used was Graylog, which I used is Graylog, and this is used for log aggregation and management. So what logs are? So logs are basically status updates and any errors or any, I would say, any anomalies that show up in the network structure will be logged. So that would be a data set that we'll be able to go through and be able to analyze to see what kind of activity that we have going on in our networks. Another thing that we will use is AT&T's open source tool, OSSIM, which is open source security information management. And that will be used as our um, security information and event management solution. So, figure four, this is the ideal network topology of how we would set up our network. So what we have here, the firewall would be our pfSense. We would like to also have or two switches. We'd also like to have wireless network device connectivity. We also like to have our servers set up there or the main controller, and then other wired channels that we can also go ahead and attach to the system. And as I said here, as you can see in the diagram, the firewall, all the traffic coming from both switches has to go through that firewall to go to the internet and vice versa. So this is the setup that was used for actually configuring the pfSense. So here we have the pfSense. We have a monitor that is used to display the command line interface of the pfSense device. Once the pfSense is software is installed, what you have to do is you have to go through a setup process, a command line setup process, where you'll be able to configure your WAN IP addresses and your LAN IP addresses. And through that, you'll be able to connect to the web configurator, which is the online version of pfSense. So to set that up, what you would need is your monitor to display that command line interface for you, your pfSense device, a PC, and a keyboard. And that's what I was able to use to configure that WAN and the LAN connection so that our pfSense will be able to operate effectively. And once you have the pfSense set up, you're able to connect to your pfSense web configurator. You're also now able to, as you can see on local PC, the first local PC, that's the pfSense running there. And you're also able to create your virtual private network through which all your other connections will be running through. Here I also have a small switch that has like 7 ports for additional connections. And the monitor is there as well. You know, if there's a case that you need to increase your local area network range, you can also use the web or the command line configurator to do so. A few achievements of this project. So the first thing, I was able to successfully configure the pfSense interface. That was kind of a challenge at first because the some of the connections were not operating as they were supposed to, and I had to like really dig deep, doing some research, trying to figure out how to get that WAN connection up, how to get that LAN connection up. When I was able to do it, I know it's operating fine. So the second thing I have to do is to set up and connect devices to the firewall, which is getting getting the internet from the router or your internet service provider, connecting that to the pfSense device, and then connecting the pfSense device to your using that pfSense device as your router for the new network. I was also able to create a few virtual machines to host the Windows server. I was using that virtual machine to host other Windows machines, which are used to host some of these free open source software such as RAfana and Snort and Wireshark. The last thing, I was able to create the virtual machine using the Ubuntu operating system, and that was because during my research, I was unable to find a simple installation process for Windows or Mac for Greylock, but I did find that setting up on Ubuntu was what should have been way simpler. So that's the route I took, and I did that using a virtual machine. Since all of these are open source software and we want all this to be virtual, I didn't have access to multiple machines. So I created virtual machines to get this process controlled, contained environment to see what I could come up with. Some of the issues that I faced during this project was establishing my own private network alongside the university's network. Now, at first, I thought, I wouldn't be able to set this project up in the CCIE lab here at the university, but when I connected to the internet, I wasn't able to access that internet, and that's because the University of Eastern Columbia does have their own network topology set up, and because of that, you have to go through different channels of getting access to that internet to set up a new route. So I had to take this project home, basically connecting it to my personal ISP internet service provider, and yeah, basically setting up at home. I needed additional software, so I actually purchased that mini switch off my own volition to set up some of the additional network devices. I also had some issues with connecting to the web configurator, connecting to the web configurator, the PSN, as I mentioned earlier. Um, so for Smart, Grafana, and Graylog, I was able to install the software, but with the configurations of the software, I did run into a few issues where with Snort, um, I was, I am running into some issues with specific installation. Everything else works, but the specific installation file that's preventing it from downloading, and I'm still doing research on that. And for Graylog, there is a database. I think MongoDB is the link or the link that I was using and other links I've been using to install it. They're saying that we need that MongoDB database in the phone. And so I am still trying to find a new way of installing the Graylog completely. So the future work of the software is to use Wireshark Graylog to set all this up on different monitors to visually display the log information on our virtual network. We already have the PFSync set up, which does have that capability. But we also want Wireshark, which is able to track the network traffic and protocols, and Wireshark can also pull specific protocols and other configuration which is in Wireshark. So we really want to get that up and running. Also, with the Graylog, can track that log information. And is there any questions online?